Hello everyone, welcome to the channel Chemical Engineer. Myself Sahil Yadav, and in this video we are going to see how we can apply the chemical engineering concepts in designing of our household items. In our previous video we have seen the designing of air conditioner. In this video we are going to see the designing of a ceiling fan. So how a fan should be selected and what are the parameters that are affecting in designing of a fan. Alright, so if you are new to the channel, so you can subscribe and you can follow us on Telegram for the latest updates. Okay, so the factors that may be affecting to the designing of a fan are room size. So if you are having a bigger room, it is but obvious that you will require more than 1 to 3. So you may require more than one fan. So if you have a bigger size of a room, you may require more fans. Second is the ceiling height. So if you are having the height of a room as, suppose in general we are having a height of a room as 6 meters. Okay, so 6 meters, or we are having in our new rooms that are 3 meters. So those designing of the ceiling height is directly proportional to the speed of a fan, so that we will see. Then fan design. Suppose we are having a fan with 3 wings, we may have a fan with 4 wings, we may see fans with 5 wings as well. So for each fan designing is different, and the speed of a fan is also a basic or the important factor. Alright, so this is a general note for which we are uh, taking a basis of designing of a fan. So humans are comfortable till the air velocity around them is below 0.5 meter per second. Okay, so if the fan is delivering the velocity of 0.5 meter per second, human bodies are comfortable up to that. If the fan speed is high, then human body feels discomfort. Why does it feel discomfort? Because the upper layer of the skin is very sensitive and it may sense higher amount of airflow through it, that is tangential to it, so it will cause uneasiness to the skin. Or moreover, those higher velocities are not advisable because they are not actually good, because some pollutants may entrap in the fan speed and may directly come towards you. So lower velocity, lower than 0.5 meter per second is advisable or is recommended. Okay, so above this velocity, top layer causing discomfort to the human mind. Now our first factor that is affecting the fan size is the room size. So what we have to do is we have to calculate the room area or room volume. So if you are having a room of 5 by 5, suppose it is having a length and width of 5 meter, as well as suppose it is having a height of 5 meter. So for that room, our volume will be 5 into 5 into 5. So that is 25 into 5, that is equal to 125. So 125 meter cube will be our room volume. Okay, so we will have to calculate the room volume, and in order to have this velocity of 0.5 meter per second, this is the thumb rule, that you have to change the room air by how much times? A 6 time minimum or a 10 time maximum. So 10 time the whole air should be replaced. We will take the maximum value for designing of a fan. So 10 times you have to change the volume of air inside the room per minute. Okay, this is important, per minute. So per minute you have to flow some air with this velocity such that 10 times per minute air is changed inside the room. Like suppose if we are having air inside this room, suppose it is V. So per minute we have to remove 10 times V. If you are having doubt, you can comment it. But 10 times of the real volume of air at the initial you have to remove per minute, per 60 seconds. Okay, so this is the basic concept for designing of a fan. So flow required, the of a fan or the speed of a fan should be equal to 6 to 10 times the room volume. For our case we will take the maximum, so 10 into 125, that is equal to 1250 meter cube of air is to be replaced. How much air should be replaced? So meter cube per minute. Per minute it should replace 1250 meter cube of air. Okay, so this is the basic concept of fan designing. It means that इतना amount of air हमारा रूम से बाहर हमको निकालना है. We have to remove this much amount of air from our room per minute. If we convert it into CFM, because CFM is the general unit of measurement for designing of a fan, so 1 meter cube per minute equal to 35.31 CFM. So 1250 will be 1250 multiplied by 35.31. So that is equal to 44,137.5 CFM. So cubic feet per minute. This much amount of air is required to be removed per minute from the room. So your fan is designed in such a way that it will remove this much amount of air. If one fan is incapable of removing this much air, then we will use two fans in a room. Okay, so this is the basic of fan designing. Then ceiling height. So ceiling height is important. Why is it important? Because we have to maintain the velocity of 0.5 meter per second. Okay, so if the ceiling is, and the human is sitting here or standing here, okay, if the ceiling is 3 meter, then rotation per minute of the fans, this wings, is around 280 to 320. So if it rotates at 280 to 320, then it is advisable up to 3 meter. If the height is more, then we require higher RPM. So ceiling height of a ceiling, suppose this is a height of a ceiling, this height is directly proportional to the RPM of the rotation per minute of the fan. So the fan, or we can say the speed of a fan, you may call it as a speed of a fan. So it is directly proportional to the speed of a fan. Okay, and if it is above 3.5 meter, then RPM will be 400 RPM. For fan will be 400 rotation per minute. So that one wing will rotate up to 400 times per minute. Okay, so that will be RPM. Moreover, if it is more than 3.5 meter, then we have to increase the height of the support of a fan. So this height we have to increase from the ceiling. Okay, so this is the ceiling height and RPM relationship. Now we will see the relationship between the RPM and a fan size. In general, in our home we are having a fan size of 36 inch, 48 inch, and then 56 inch. Okay, so general these three are the standard size of the fan. Fan size is measured from the distance of one wing to the center. Okay, so the distance from the wing corner to the center, if it is 36 inch, then we may call it as a fan size of 36. So if the fan size is 36, RPM required is 350. 48 RPM is this and this. So what we got to know from this is the fan blade size, we call it as blade only, okay? Blade size is inversely proportional to the RPM. And in our previous slide, we have seen that RPM is directly proportional to the height of the ceiling. So we may call that blade size is also inversely proportional to the height of the ceiling. Is it true? No. Why is it not true? Because this is not an ideal condition case. Okay. Blade size is independently designed on the basis of RPM. Both are independent variables. RPM and blade size are dependent on each other. But blade size and the height of a ceiling, those two are independent of each other. So there is no relationship between the blade size and the height of the ceiling. Okay. Then RPM and CFM relationship. So if you are running a fan at 200 RPM, CFM it will give is 4000. If it is 300, then we have 6000. If it is 400 RPM, then it will give the 9000 CFM. In our case, what was our CFM? Wait, let me check. What was our CFM? Our CFM was 44,137. Okay. So for 44,137, we may require how many fans? Okay, wait a minute. For 44,137, in order to achieve this CFM, what can we do the best? So you are having more than these three are the main options. You have to select how to design a fan, selecting any of the combination. In order to achieve this, what we will do is we will use fan of 450 RPM, which will be having a CFM of 12,000. What we will do is we will use 450 RPM smaller fans, and we will divide it into four phase 1 2 3 and 4. So four fans can be placed in this room of a 5 by 5 meter, 5 meter by 5 meter, and the height is 5 meter. So four fans can be placed at four different location. So if we divide that volume into four parts, so 125 meter cube, if we divide into four parts, it will yield into 30, around 30 meter cube. So for 30 meter cube, we may require uh, how much of the CFM? So it will be required around 10,000 CFM. If we divide this into 4, so 10,000 CFM will be required per fan. So we will install a fan with 450 RPM, which will give the cubic feet per minute of flow of air as 12,000. So we will install 4 fans in our room. So this is how we can design fans. Okay. Now, okay, so this is all about the designing of a fan. If you want to know how the motor of a fan is designed, then you please comment it, or you please message in Telegram. I will be happy to upload those videos. So I like to share this basic understanding of my chemical engineering concepts. So thank you for watching the video, and if you want an Excel sheet of the relationship of a fan directly, I will have an Excel sheet which will give you the best choosing of a fan or the selection of a fan as per your room diameter or the sizing. Okay, so that Excel sheet is not free at all. That Excel sheet will be chargeable of rupees 50, but that Excel sheet is enough for you to understand the designing of a fan fully. There will be a presentation. I will have a different presentation, as well as I will be giving you that Excel sheet in which you just have to write down the dimension of your room and the fan with its size, CFM and RPM will automatically comes to you, so that your fan selection can be done easily. All right. So by that doing you can save money, because in market there are many fans, and we buy almost every 90% of Indian buys a fan which is overrated or not required as per his room capacity. Okay, and that's it. So thank you for watching. Subscribe to the channel and stay connected. Thank you.